Okay, in this presentation we're going to look at the log normal distribution. So we'll start off with this variable y, and y is the log of x. But we're also told that y is a normally distributed random variable with a mean of 10 and a variance of 4. So y is normally distributed, okay? 2 squared, okay? So that's the important thing here. So we're asked for the PDF of x, the probability density function, the mean and variance of x, and the probability of x being less than 1000. Now, so we got some definitions and formulae down here below, but essentially what we have to have clear in our minds is what is actually the log normal distribution. Okay, so it's a continuous probability distribution of a random variable whose logarithm is normally distributed. Okay, so the log of the variable is normally distributed. Okay, so thus if the random variable x is log normally distributed, then y, which is the log of x, the natural log of x, has a normal distribution. Now that's important actually to sort of get the order right in your head, because if you were to expect the logarithms to be of a normal random variable to be normally distributed, you're on the wrong track. That's what I'm saying. So the logarithms are normally distributed. So that is fairly important here. Okay, so you could go very wrong very quickly by having this not clear in your mind. Okay, so that's it really. There's a couple of other definitions there, but for this one, what we need is the mean. What we have to do is write out the PDF of the log normal distribution. Okay. And it's not entirely different in form from the normal distribution. So the key parameters are sigma and mu, or actually really I should go mu and sigma, but it doesn't really matter. So we have x times sigma times 1 or times the square root of 2 pi in the denominator here. So we have lambda, or sorry, we have a sigma there. Okay, we have sigma there also, and we have mu there, but otherwise it's fairly straightforward. Okay, so this definition should be given to you in the back of your exam paper or formula sheet or something like that. Just actually the mean and the variance will be given below. Okay, so essentially really it's a matter of determining what mu and what sigma are, and here we have them there. So mu is equal to 10 and sigma is equal to 2. So really what we're going to do with for the first two questions here, this one and this one, is actually just put them into these formulae. Okay, so f of x is 1 over 2x times the square root of 2 pi times the exponential of minus log x minus 10 to be squared over 8. That is 2 sigma squared equals 2 times 2 squared equals 8. Okay, that's what's going in there. Just down here we have lambda. Sorry, why am I saying lambda? Mu there. Okay, and 2x comes from here. So sigma is equal to 2. So we have 2x down there. Okay, so it's really just actually putting the numbers in and putting them in the right place and simplifying them accordingly. So we have that 8 there. Okay, now just for the 100% correct answer, you can specify it out like that with the cases for x greater than 0, greater than or equal to 0, okay, and 0 otherwise. That's just the sort of key thing about the log normal distribution. It is, it has to be, the outcomes have to be positive numbers. So it has a support of 0 to infinity. Basically, it has to be positive, okay? That's a thing called the support, okay? Basically, what are what's the range of possible values? Okay, so part B, again, actually, so this is straightforward enough. What we're going to do here is use our formula, these two here. And again, mu is equal to 10 and sigma squared is equal to 4, so we should get 12 there. Okay, 4 over 2, okay. Did I do that right? Sigma squared over 2, yes I did. So that's 12, so 4 over 2. Okay, which works out to be 162.754. These numbers actually get quite big quite quickly, so I'm not necessarily going to expect you to write them out fully. Something very similar here for the variance, the exponential of sigma squared of y minus 1, so that is the exponential of 4 minus 1 times the exponential of 2 times mu plus sigma squared, which is 2 times 10 plus 4, which is the exponential of 24, which is actually a really, really big number, so we'll just leave it like that. 53.598 times the exponential of 24, which is a massive number, but anyway, don't worry about that. Now, so what we're asked for in the last part here is the probability of x less than or equal to 1000. Okay, that's tricky. So we're not really given any guidance here. So let's go back a second. We're not really given any guidance here about how to do probability calculations, are we? But we know that it is we can just express things in terms of the logarithm. So the probability of x being less than 1000 is equal to the probability of log of x being less than log of 1000. And we know that the log of x is y, and we know that it's normally distributed. So essentially, we can turn this into a normal distribution question now. Okay, so log of 1000 just treat it as some number with mean of 10 and standard deviation of 2. So get the z-score there. Log of 1000 minus 10 divided by 2, okay, which is minus 1.55. If you're familiar with this phi expression there, if you're trying it out with a calculator or something like the R programming language, you might use that formula there, p norm. And there, that's the answer there. So some way or other you should get down to 0.0611. So that's the answer to that one. So essentially, this actually is straightforward enough, part C, but it's because we're looking at it from the point of view of y, which is a normal random variable. Okay, so y, again, going back up here to something I said before. Where did I say it? Up here, just think in terms of y. All right, we'll leave it there. That's grand. Leave it there.